All right, welcome to section 4.6. In section 4.6, we're going to be talking about all the rest of the graphs of the trig functions. So all the other four, which is sort of cool. You know, we got two of them out of the way and now we just jump into all the rest. Because if you've mastered sine and cosine, or even if you're generally okay at sine and cosine, this isn't going to be too different. So remember, the graph of y equals tangent x. Remember that what tangent is equal to is sine x over cosine x. So what that means is that when sine of x is equal to 0, tangent of x is going to be equal to 0. Because if the numerator is 0, the function will be equal to 0. If cosine x, the denominator, is equal to 0, that means that tangent is undefined. What that means is that the graph of tangent x is going to have vertical asymptotes any time in which cosine of x is equal to 0. Because if cosine is equal to 0, tangent must be undefined, which means I'm getting a vertical asymptote. All right, so talking about the graph of this, the period for tangent and thus cotangent is different. In this case, it's going to be pi over the absolute value of b. And amplitude does not apply to tangent, and you'll see why when we graph it. So amplitude, that doesn't apply to tangent. However, and you'll see it in questions, we'll put like amplitude in quotes. The idea of amplitude is still going to be helpful for graphing, even though it's not technically called amplitude. Your 5 key points for the tangent function. So for tangent function, the points go 0, 1, undefined. It's a terrible undefined, sorry. -1, 0. That U, again, just representing undefined. And these are talking about your y values. Your x values are still found in the same way. You do just the midpoint of the period and so on and so forth. However, the period, it's important to realize, is pi over the absolute value of b, not 2 pi over the absolute value of b. So then just an idea of what the tangent graph looks like. Here's our tangent graph. If we were starting at something like 0 and going to something like pi, which is 3.14, so right here, our y values go 0. We've got 1. We have undefined. We have -1. And we have 0. So there you can see 0, 1, undefined, -1, 0. Again, starting at that origin still, or starting at the y-axis, and moving left to right. So this is what our tangent graph looks like. And you'll notice that there are an infinite number of these vertical tangents because the function is just going to keep repeating itself. If we talk about cotangent x, so now we're talking about the reciprocal of tangent. The period is found that same way, pi over the absolute value of b, and the amplitude once again does not apply. If we talk about the 5 key points, so over here, if we think about tangent x, we said that our 5 key points for tangent were 0, 1, undefined, -1, 0. Cotangent is the reciprocal of tangent. So all you're doing is taking the reciprocal of each one of these. The reciprocal of 0 is undefined. The reciprocal of 1 is 1. The reciprocal of undefined is 0. -1 is -1. And 0 is undefined. So your 5 key points, and again, these are y values, for cotangent would be undefined 1, 0, -1, undefined. You know, it might be a little bit much to be like, oh, I got to memorize the cotangent as well. No, if you memorize tangent, then cotangent, you know, you're just doing the reciprocal of each one of these. All right, so using that same idea of reciprocals, remember that secant x is equal to 1 over cosine x. So on our little list, if cosine is equal to 1, that means secant is also equal to 1. Because if I had cosine x being 1, then I'd have 1 over 1. And if cosine of x equals 0, secant of x is undefined, which means that it will also have vertical asymptotes. Any time in which cosine of x is equal to 0. So, here, this is just our cosine graph, just cosine x. If we're talking about secant, that's going to be on our next slide. So here we have the secant graph. And just to clarify, I'm going to do some different colors here. 1 second. Here we go. So this in red is not secant. What's here in red is just cosine. Where is that? There we go. This is cosine x. What I'm now going to highlight in blue, don't know why I keep going there. In blue, we have what is, oh gosh, wow, I don't know how to highlight. In blue, we have what is actually the secant graph. So, there we go. In blue there, here we have secant x. Now, some things you can notice about secant x. Here, cosine is 0. That's where I have a vertical asymptote. Here, cosine is 0. That's where I have a vertical asymptote. Here, vertical asymptote. And here, vertical asymptote. Another sort of cool thing is when you talk about cosine, cosine goes from -1 to +1, and it just keeps bouncing between those. Here it is oscillating between -1 and +1. Secant x as the reciprocal of that, you can never get anything between -1 and +1. So looking at this blue function, I can get any y value from 1 on up or -1 on down, but nothing in the middle. When we go through the graphing of secant, and just to talk about secant's coordinates, when we go through the graphing of secant, there's going to be 2 ways that you can do it. One of them requires that you draw cosine first, and then one of them is just using the points of secant. And I don't particularly care which one you do. So if we think about the points for cosine, cosine is 1, 0, -1, 0, 1. And if we're talking about secant, secant is the reciprocal of this. So 1 undefined, -1 undefined, 1. Notice there are no zeros, and in blue, I never touch that x-axis because there are no zeros. All right, moving along, the cosecant graph is going to be similar. So if we're talking about the cosecant graph, we're going to use sine as a guide. So remember that sine of x. Sorry. No, I know, erase. We're talking about cosecant. Cosecant of x is equal to 1 over sine x, which means if sine of x is equal to 0, cosecant x is undefined. So any of these locations, I know that I'm going to have vertical asymptotes. So if we decide to go look at this graph now, same thing applies as last time. That graph that's going on in the middle, that is sine. If I'm talking about cosecant, the only thing that actually makes up cosecant is what I have here in blue. And you'll notice that it looks very similar to the secant graph. Oh, gosh. It looks similar to the secant graph, but so does the sine graph. The sine graph just looks like a cosine graph that's been shifted. And a cosecant graph just looks like a secant graph that's been shifted. So here we have cosecant x. Again, I have vertical asymptotes anywhere in which this sine function it was equal to 0. So if we talk about these y values again, secant and cosecant, things that you're going to want to know. I'm just going to list over here cosine x, sine x. So sine goes 0, 1, 0, -1, 0. Cosine goes 1, 0, -1, 0, 1. Secant and cosecant are just reciprocals of that. So 1, undefined, -1, undefined, 1. Cosecant is the reciprocal of sine. So undefined, 1, undefined, -1, undefined. All right, that's all we're covering in the notes is just, getting down those points, those y values, all the same rules that we dealt with in section 4.5, graphing sine and cosine, still apply. Shifting, applying the amplitude, reflections, that's all the same. So essentially, this boils down to make sure that you know the 5 points for secant, cosecant, cotangent, and tangent. And then also realize that the period for tangent is not 2 pi over b, but pi over b. And that's for cotangent as well. Jot down any questions that you might have so that we can answer them before we get started on the rest of the bookwork.